Tanisa, now am I audible or still there is a problem in listening me? Am I audible?
Still not able to hear you, sir.
Okay. I don't know what is going on actually. My mic. Now it's audible or it's still it is the problem. I have removed the mic. Are you able to listen me? Tanisa?
Yeah, I can hear you now, sir.
Okay, you can hear me now. I'm going to join this again. Then let me know for one more time. Okay.
Yeah. Okay.
If it will not be audible, then I will remove it completely for the whole day.
Okay.
Yeah. Tell me it's audible or not.
Yeah, sir. I can hear you.
Okay. Okay. Perfect. Okay, Tanisa. So you are in year 11 classes, right? You are taking year 11 classes.
No, sir. You're 10.
Tanisa?
GCSE, you're 10.
Okay. Okay. IGCSE
You're 10.
Edexcel 10. Year 10. Okay.
Yeah.
Okay. So let's take some topic for a proper demo, right? If you want to share with me any topic of your concern, then we will go with that. Otherwise, I will select one of the topic which will be best suited for the demo. For 1 hour, that will complete. Okay.
Could you let
Just
me
in
know
1 hour.
which topic it is? Because I'm not sure if I've done it or not.
Okay. Let's talk about, I'm giving you 3 options. Momentum. Have you heard about this term? Momentum?
I have heard about it, but we haven't done it in class yet.
No problem. Vector and scalar quantity?
Yeah, we started it, but then we haven't learned it in detail. We have.
No problem.
Yeah.
So let's talk about then vector and scalar. After discussion of this, you can compare whatever the method of mine to explain the things. You can compare with the school teachers, and it will be more easier to decide for you how was this lecture or not, right? Okay.
Yeah, sure.
So let's talk about some quantities, scalar and vector. You know that vectors and scalars are the two kinds of quantities, right?
Yeah, there are
Vectors,
two quantities.
Yeah, vector and scalar. So first of all, let me know if you have any idea about that. Why we are talking about these two kinds of quantities?
Vectors and scalars, they're quantities, but vectors have they are quantities which have a direction, whereas scalars only have mass quantities. So suppose kilograms, suppose mass.
Okay. So
weight.
Yeah, you're saying properly. There is nothing wrong. Everything is perfect. But let's try to understand it more better way and with some examples too, right? Then you will feel that something you are missing.
Okay.
Right. After the explanation, you will get a better understanding, a better feeling about the vector and scalar quantity. So for that, first of all, I have to give you some examples why we are talking about two kinds of quantities, vectors and scalar, how these kinds of quantities come into picture actually. So let's talk about an example in which there is a manager, right? And there is a secretary, and there is a person whose name is, let's say, Tanisa. Okay. And manager trying to call Tanisa. He told the secretary, please call the Tanisa, and the secretary trying to call because secretary didn't see ever, right, Tanisa, who is Tanisa and these things. So only she knows about the Tanisa that his name is Tanisa. Only she have this much of information that his name is Tanisa. Okay. But the problem is what? There is more than one Tanisa. Let's say there is 5 or 4 Tanisas. And tell me, with this only information that her name is Tanisa, she will be able to call that exact Tanisa about which manager is talking, or she will face any problem?
He will face a problem because he doesn't know the exact details of the person.
Yeah, she have only one information about the Tanisa, that his name is Tanisa, right? She
Yeah.
need one more detail about that Tanisa, like Tanisa Raghavan, Tanisa Sinha, Tanisa Srivastava. There are different kinds of surnames, or in other way, the you can say the Tanisa, his hair is brown, the Tanisa, his hair is black. This different kinds of informations. There is one more information required about that Tanisa, which she have only, right? So
Yeah.
in this manner, there are some quantities for their complete description. There are some quantities for their complete description. They need the information of magnitude because they are quantities, so they will exist in the amount, right? Like 2 kg, 3 kg, the masses, right? The
Yeah.
forces are 4 Newton. These are the first information about the quantities. And with that information, the magnitude, the information of magnitude, they required one more information of direction as well.
Okay.
Why? Because of the same reason. Explain, there is a block, right?
Yeah.
And this block is experiencing 4 Newton of force, right?
Yeah.
And I'm just observing this whole phenomenon, and I'm trying to explain, or I'm trying to express my friend which is not watching this. I'm on the call, I'm just trying to express what is the things are going on, right? So I want to say, my friend, hey bro, what I'm watching here, that there is a block there is a block of 4 Newton force is exerting over that, a 4 Newton force is exerting over that. Only this information I'm sharing with him.
Yeah.
So tell me, he will be able to got the exact happening, what is happen here. He's able to, there is one more force, which is the 4 Newton. There is this kind of 4 Newton is also, all the forces are 4 Newtons, but he will understand exactly about which force I'm talking. I have just told him,
No, it
hey
could
bro, I'm
be
watching
a
4 Newton.
gravity force or it could be a pull and push force.
There is a possibility that he will understood about this, right? He will imagine about this force. What I'm watching here, I'm watching that a 4 Newton force pushing the block and causes to move in
Yeah.
forward direction, but he will assume that in his mind a 4 Newton force is crushing object, compressing the object, right?
Yeah.
Against the surface. So this will be the problem for him, right? So
Yeah.
what is the thing about which we have to talk once more? So we have to, for the complete description of force, we have to use the information of direction also, right? Because there are
Yeah.
two forces of 4 Newton.
Yeah.
Both the effects are same. Both of them have different effects. So, but the name is same, 4 Newton. One more information required for their complete description. And what is that? The direction. I have to tell, hey bro, I'm watching a 4 Newton force which is acting in forward x direction, positive x direction, right?
Yeah.
Then he will realize exactly what I'm talking about, right?
Yeah.
So, so this 4 Newton will be which kind of force? Vector, right? This 4 Newton of force, the force is a quantity which we call vector quantity, right?
Yes.
So the quantity which requires the quantity requires magnitude as well. I'm writing some words in short form, right? As well as the information of direction also, right?
Yeah.
For their complete description, for their complete description. So this is the proper definition about that.
Okay.
Okay, let's talk about the some scalar quantities. Like we have a weighing balance, or we all have seen this kind of weighing balance. Have you seen that?
Yeah.
Right.
Yes.
This is the traditional weighing balance. Okay.
Yeah.
Let's say I want to analyze the weight of the let's say 2 kg of sugar, right? I don't know the weight of the sugar is mass of the sugar is 2 kg or not, but I'm expecting that the sugar have mass 2 kg. This is the bag in which sugar is present, right? I'm placing over here. So how I will ensure that, how I will get correct observation that the sugar have 2 kg mass, I have to place something here, right, of 2 kg.
Yeah.
If the sugar bag will balance with this 2 kg, then it will be of 2 kg. So for that, I'm asking to my friend, hey bro, just give me the 2 kg. So during asking that, that person will ask another question that will that person ask another question that, hey, which kind of 2 kg? The stone of the 2 kg of stone, the 2 kg of wooden block, that direction of 2 kg or that direction of 2 kg. This question is
It doesn't make
relevant
sense
here. Yeah, of course. We only need 2 kg, or any 2 kg are the same kind of 2 kgs, right? If you will give me 2 kg of stone, doesn't matter, that will compare and balance and it will give me the result. If you will give me the 2 kg of metal block, again, that will give the same results, because every 2 kgs are the same kinds of 2 kgs. It doesn't matter, it doesn't need any other kinds of information which kind of 2 kg. Every 2 kg are the same thing, right? If you will and wear some gloves, some types of gloves, and I will place some 2 kg object, let's say stone, and after replacing that, after removing that, I will place some other 2 kg of, let's say, metal block. Then you will not be able to distinguish between them, because both the experiences are same, because both the 2 kgs are the same 2 kg, right? So there is no need to any other information, right? So which kind of this quantity? Mass, which kind of quantity? Scalar quantity, right? You got it. Let's say any other example also for more proper deep understanding. One day what happened, one student, I was teaching in the class, and one student just enters into my room, in my classroom, and he looks very tired. He looked very tired, and I was just asking that, why are you looking so tired? So he told me that, sir, actually I'm coming from 1 kilometer, 1 kilometer. And now tell me, there is the requirement of the answer or another information that from which direction of 1 kilometer you are coming, that direction or that direction. What is my question actually? My question is, why are you looking so tired? So there is any need to ask from which direction? From any direction, if you will come from 1 kilometer, you will face same kind of tiredness, right?
Yeah.
So there is no requirement of any other information, right? Yeah. The only information required, how much kilometer, right? 1 kilometer. So this gives the answer completely, right? But what happened in next day? He wants to invite to his home for celebrating his birthday. Okay. And now I have only one information, that his home is 1 kilometer far from my coaching institute. So now tell me, am I able to reach their location with this only information? That
direction given.
Yeah, in this situation, that 1 kilometer in this direction or in this direction, all the different all of them are 1 kilometers, but their effects ultimately will be different, right? So in this situation, we need one more information like direction here. So we place that distances in two different categories. In first category, distance, where only the magnitude required, we call them scalars. And in other category, in which this magnitude as well as direction of distance also required, that we call them displacement. right? We give the another name properly to not be confused, right?
Yeah.
Displacement. It is nothing but distance in a particular direction. Distance. It is also distance, but with the information of direction also, right? Distance in a particular direction. This is only distance, right? This is scalar quantity, and displacement is vector because it involves the information of direction also in a particular direction. Understood the concept?
Yeah, I did.
Yeah, this is the thing. Which quantity will be a vector quantity or which quantity will be scalar? It will be completely based on the experience, right? You have to see for the quantity, for their complete description, that quantity needs only magnitude, or that will need one more information like direction also, right? Like the time here, sometimes just I will say, please come to my home 2 o'clock. Then you will need one more information, or
Yeah, like 2 o'clock
yeah, you
AM,
will
like is
then
it AM or PM or
yeah, of course, because there are two kinds of 2 o'clock, right? But 2 o'clock, but the time is a scalar quantity because it doesn't need the information of direction, right?
yeah,
Here, for to be vector quantity, the quantity needs one more
direct.
information as direction, then it will be vector. Otherwise, we call them scalar quantity, right? So the
Yeah,
quantity which requires only magnitude for their complete description, right? For their complete description, we call that scalar quantities, right? What are those? So mass, time,
speed.
yeah. First of all, that distance, and then speed. Speed is formed from the time and distance, right? Information of time and distance. It needs for their description distance and time, and you know that time and distance are scalar, so speed will also be scalar because
Scalar.
the scalar will give scalar, right?
Yeah,
And there are another quantities like energy, lots of quantities you will see one by one in the discussion, right? Here, what are those? Displacement,
force.
like distance and displacement. Like distance and displacement, there is a velocity, the quantity which sometimes need only the magnitude, we call them speed. And when that quantity will need magnitude as well as direction, we call them velocity. We give them a different name, don't be confused, for not confusion, right?
Yeah,
So velocity, force, and force results acceleration, right? Force is the reason behind acceleration, so acceleration will also be a kind of vector quantity, and
yeah,
acceleration is also coming from change in velocity, right?
yeah.
Acceleration, I'm writing in short form, and the
Weight.
momentum, and there are different weight is also kind of force, right? So
Yeah,
weight will be also considered as the vector, right? So these are the examples. Have you understood properly this
yeah, I
topic?
did. Yeah.
So let's talk about any other concept. Uh, so they have discussed anything about distance, displacement, speed, time, these kinds of things.
No, we
Speed.
didn't do anything more than this for vectors and scalars.
Okay, no problem. So let's talk about any other concept like momentum. This is very
Okay.
interesting topic.
Yeah, we haven't started momentum
Because
yet
a
though.
little, so
But
the very
I
beginning,
have
in the very
I
beginning,
mean
the
like they
first.
started it in school last year, so it should be fine, I think.
So you want to discuss this momentum, or
Yeah, momentum is
I'll,
fine. I can discuss, like we can discuss it.
okay, let's talk about them. Otherwise, I can start from the term motion, because motion is the exact first term we have to discuss in the beginning of your year 10, right? Okay, so let's talk about momentum. What is momentum? It is nothing but it's a quantity. It is also quantity, amount, and other thing. It is a quantity which gives some information, right? Which kind of information? It is a quantity which informs us about that how hard to stop something, to stop some moving object, right? How hard to stop any moving object or some, you can write here any moving object, right? So with the information of momentum, you will get some idea that it will be hard to stop the object or it will be easy to stop the object, right? So let's talk about some example for understanding this. Let's say there is a bus which is very huge, right? The mass is very, very large for it. Let's say its mass is 55,000 kilogram. You know that what is your mass? It will be nearly 50, 45 or 55, right?
Yes.
It will be in between 40 and 55, right?
Yeah.
And let's talk about this. It's 1,000 times more than this, more than your mass, right?
Yeah.
So it's this is extremely huge, right? And the velocity with which it is moving, it's very, very low. Let's say 0.03 centimeter per second. It's very, very low speed, right? It just started to move.
Okay.
I want to know, tell me, are you able to stop this with your bare hand? Is it hard to stop or is it easy? Is it hard?
It would
for
be
you?
hard because
Or
the mass is more. It's a
it will crush you, of course. Yeah, of course, the speed is less, but still, it is very, very hard for you. You cannot stop it with your bare hand, right? Is it hard to stop? Yes, hard to stop. So, yes. Why? Because of its mass, right?
Yeah.
Because of its mass. Yeah, it is moving with very less amount of speed, but because the mass is very, very large, it will crush me, right? It will murder me. So let's talk about any other object which is very, very light. Let's say this is a bullet and its mass is very, very small. Let's say 0.03 kg, 0.003 kg. Okay, it's very, very lightweight. Tell me, it is moving with some speed. You know that what is the speed of sound? It is very, very huge, right? I'm just I'm just clicking something and it immediately reaches to you, right?
Yeah.
So that is 340 meter per second nearly. It's very huge amount of speed, right? So near about the bullet is also moving, let's say 290 meters per second. The bullet is moving with 290 meter per second. Now tell me, it will be hard to stop with your bare hand or it will be very easy for you because mass is very, very less?
It'll still be hard because of its force, because of the speed it comes at.
Yeah, but mass is less. The speed is very, very huge here. It will again murder you, right? You cannot stop that with your bare hand.
Yeah.
Yeah, yes, it is hard because
of its speed.
Of its, or you can say velocity, right? Because in this situation you need direction also, information of direction. Also, I will talk about that in later classes because of its velocity. So now you got the idea that if the mass will be huge, then it will be hard. If its velocity will be larger, then it will also very hard to stop, right? So there are two factors over which the hardness to stop the object depends, right? And what are those? Mass and speed.
Speed.
If any one of these, if any one of these is more, so it will be very hard for you, right? So momentum is basically about the mass, about the information of mass and velocity, right? It collectively gives the information of mass and velocity in single information, right? So basically momentum symbolized with the symbol p, and it is directly proportional to mass and directly proportional to velocity. Directly proportional means if mass will
If the
increase,
mass increases,
momentum will increase. Momentum is what? Momentum is what? Momentum is that quantity which will inform us about the hardness to stop, right? So if the mass will increase, then it will be very hard to stop. Of course, if you will increase the mass, then you are increasing momentum. If you will increase velocity, then again you are increasing momentum, right? Because the information will be more, right? So momentum will be equal to what? Mass times velocity. If it will be more value, let's say this is what amount 2 and this value is 3, it will be how much? 6, right?
6.
If I will increase 2, if I will increase if I will double the mass, then what will happen? It becomes 4 times of 3. Now the total value is how much? 12, right? The total value is also increasing here. Now if I will double the velocity, what will happen?
4 times 6, it will be 24.
Again the total value will increase, right? So this formula becomes the product of mass. If you will take the product of mass and velocity, multiplication of mass and velocity, then you are taking the collective information of the mass and velocity, right? Because both the factors are responsible for hardness to stop the object, right? Both the factors are responsible. So in the multiplication of these two, both the information included, right? Simultaneously. So we don't need to talk about mass mass and the velocity separately. Now we have taken them as a multiplication of them, and the collective value will give the one information like this, right? The product will give one information, and that one information will inform us that it will be hard or not, because if any one of one of them will more, then the total product will be more, right? Total multiplication will be more, and this will inform the value is more, it means one of them or both of them are more here, right? If value is total value, the multiplication, the result will be more, it means one of them is more or both of them is more. It means it will be harder to stop the object. Are you getting my point? Momentum becomes the product of mass and velocity, which indirectly informs us about the hardness, that how hard to stop. Understood?
I do.
Basically, momentum is a kind of vector quantity, because what involves here? Velocity, right? For discussing momentum, you have to discuss about velocity. It means you have to discuss about the magnitude of velocity with the direction. It means you are talking about direction also, so it becomes a kind of vector quantity, right? It is a vector quantity, right? And what should be the unit of that? How you will form the unit? In the formula, what is there?
Kilograms.
Yes. Mass has kilogram, and so unit of momentum. So mass have what? Kilogram. And velocity have meter per second, right? Remember?
Meter per second.
So it will be what? It will be kg meter per second. This is the unit. In this manner, you can form like force have formula what? Mass times acceleration, right? So mass have unit kg, and the velocity have unit what? Meter per second square. Right here, for velocity it will be meter per second. For acceleration it will be meter per second square. So kg meter per second. In the same manner, you have to form all the time the units, right? I will explain one by one how we are forming actually, right? So these are the informations.
Yeah.
This properly, momentum concept also.
Yeah, I
Right.
understood. Yeah.
We have a class at 6 p.m. or 6:30.
6
Correct.
p.m. It's only 1 hour.
Yeah, yeah. No, we have started the class 6:30, right? We have half an hour, right? So anything else you want to discuss? Is it understandable for you
Yeah, I
properly?
can understand. Yeah. Could we discuss waves?
Mhm.
Waves.
Waves, weight or waves?
Waves.
This one or this one?
Waves.
First or second?
Waves. First
First
one.
one.
First one.
Okay. Let's talk about the waves. Okay, this is the very fascinating topic. Actually, they are asking to me that when student have joined, let me inform them 6:30, right?
We actually
6:30
started at
p.m.
like 5 o'clock, so isn't it supposed to be 6 o'clock?
Okay, you are in Dubai. You are
Yeah.
in Dubai.
Yeah.
Oh, so yeah. So here in India, it will be 6:30. It was
Oh,
6:30.
okay, yeah.
Actually, one and a half. There is a gap for 1.5 hours.
Okay.
So waves. Let's talk about. Okay, waves are basically waves are the ways to transfer information, right?
Yeah.
Let me first inform about definition, then we will talk about more deeper in deeper manner what is the meaning of definition.
Okay.
So basically it is the disturbance travels, it is the disturbance travels through the medium travels through the medium without traveling of medium particles, right?
Yeah.
Medium particle. So disturbance, what is that? Let's say there is a pond, very still. What the pond is doing? So pond is still, right?
Yeah.
So pond is still. Now what you will do? You will throw some stone, and what will happen?
It will create a ripple.
The disturbance will create here, right? So you
Yeah.
are developing some disturbance. It was in a still state, it was in a stationary state. Now you have disturbed
Yeah.
that portion of the water from their stationary state. Now what will happen after that? This disturbance will be carried forward by the just medium particle, right?
Yeah.
Now after some time what will happen? This disturbance will reach this location, right? And this disturbance will reach after some time to this location, and it will travel through the pond, right?
Yeah.
So the disturbance travel through the medium. What is the medium? Water is the medium here, right? What is
Yeah.
the medium? And in this, what is going on? The water particles are moving from here to there, or only the disturbance are moving from one particle to other particle to third particle.
Disturbance
Only the
moves.
disturbance is moving.
Particle moves.
Yeah, only the disturbance is moving, not the particles here, right? So let's say there is another example. This is the tight string, and this strings one end is tied to the wall, and one end is in your hand, right? And you are placing some disturbance in it. And tell me what will happen. This disturbance will travel, or the whole string will travel from your hand.
The disturbance will travel
Am
through
I
the
audible?
string. The disturbance will travel through the string.
Oh my god, something is problem there. No. Okay, my laptop screen was blank for little time. Okay. So
Okay.
what will happen? Disturbance will travel, or the
The
whole string will move?
disturbance The disturbance travels
Yeah.
through the string.
Right?
Yeah.
The disturbance will travel. Understood?
Yeah.
So what is going on? This travel, this movement of disturbance through the medium. What is their medium? Medium is the string. The disturbance is traveling through the medium because medium, the strings particles are vibrating, and due to vibration of string particles, they transfers their vibration by disturbing the another particle, right? So who is disturbing? Medium particles. So due to by the disturbance of medium particles, this disturbance carry forward to another particles, and in this manner it is traveling, right? So there is important thing is that the medium particles are not going here and there. They are only moving, but they are not moving from one location to some other place, right? They are moving from about some point, and they are still at the localized region. They are present at the localized region, right? They're not going here and there. So this is very important to us. If you want to communicate on the moon, right, any person which is present on the moon, so what you will do? You will throw some stone to them, so that you will transfer some. You will transfer some what we can say the information or any kind of information by the wrapping some stone by binding some information to the stone, and you are going to throw the stone to the moon. It will be feasible for you? No, it will be very, very difficult for us. How we can send the information? So in
Satellite waves.
case of in the case of vibrations, in the case of in the terms of disturbance, which is only the thing which is traveling, there is no need to throw something, right? We have to just generate some disturbance, and that disturbance will travel, and they will receive that disturbance, and we have coded some kind of information in that disturbance. Are you getting my point? So in this manner, they becomes very, very important to us. It's a way to communicate, right? In this way, actually, the mobiles are working. And in the last, yeah, you can say 400 to 500 years ago, what in India, actually, there is a very big intellectual. His name is Birbal, right? And he have done some experiment about the waves. What's happened? There are a few people, there are a few persons, and the Akbar is the king here in India, was the king in India, and he wants some information from deep location, right, from some distant location. So how he will get that kind of, he would get that kinds of information. What was happened in those days? Some people, some of the any person got some information. He just running through the whole distance, and then he will go to the he will go in the dargah, we say, and he will inform the king that what is going over there at that distance place. So Birbal finds some kind of trick or method to travel quickly, efficiently, to transfer quickly and efficiently the information. And what he does actually, he placed some person here with some drums, right? And the person drumming, there is some drums, and what is going on? If one person from this location gets some information, he starts drumming that drum, right? So he starts beating the drum, and with the sound of that, this person will start beating, right? And then it will also start. So in this manner, with the help of that sound, the Akbar got the idea that something is going on there. And what is going on there? So it will be coded into the different kinds of sounds, right? If that kind of sound, then that means a different meaning. If that kinds of sound, that means the different meaning. In this manner, they starts communicating what they are using there. Sound, and sound is nothing but a wave here, right? Yeah, are you getting my point? So waves are the critical things, help to communicate from a distant location without sending some heavy thing, right? So it will becomes a very, very important thing for us. That's why we're getting this concept, wave. In this, what is the important thing? The disturbance travels through the medium here, and disturbance needs some kind of source, right? Here you have thrown some kind of stone, right? So when you will start disturbing here, and that disturbance will travel through some other place, that other person will receive that disturbance. He will just figure out that why this disturbance is coming, because somewhere someone is there who's trying to send something to you, right? If you are very far apart, then what you will do in night, in darkness, what you will do, you will try to blink some torch, right? So blinking of torch, that person will understand someone is there, right? Someone is there. Otherwise we cannot see this kind of blinking, right? Blinking of light. You are communicating. And what is the light? Light is the wave, electromagnetic wave. You are traveling the wave. You are transferring the wave here. Are you getting my?
Yes,
in all case of you can clearly see there is the role of wave, right? So these are the waves here. So it is the disturbance travels for medium without traveling of medium particles. So this disturbance is nothing but the movements, right? Movements which is carry forward to the handovers to the other particle, and this movement handovers to that other particle. The particles are not going, just they are vibrating with their location, and due to that vibration is traveling through this. And this motion, we know that every motion have energy, right? We know that every motion, every moving object have energy, right? You don't want to come in front of moving train, right? You will not want in front of moving train. Why? Because moving train have lots of energy that will destroy you. Okay, so if I will throw a ball towards you, you will dodge from the ball, right? Why? Because that ball will
it has energy.
destroy your
It might
eyes.
hurt
Okay,
you.
every moving object have energy. They have ability to force and cause displacement to destroy something, right? Every moving object have energy. And the other thing is momentum also, right? Because momentum is the information of velocity. So we define this wave in another manner. The waves are the you can say the waves are the phenomenon in which the waves are the phenomenon in which the energy and momentum transfers, right? Transfers from one location to other location without transformation of any matter. Okay, so I'm saying something. The sound is traveling, and sound carries energy, and that collides with your eardrum, and eardrums starts vibrating. Eardrum receives that energy, and eardrum becomes energetic, and eardrums then collides with the optic nerve ions, right? And that ions get some energy from that vibration, and that energy travels through your brain, and you experience that as a sound. Are you getting my point? So what is going on here? Energy transferring in technical manner, scientists says in this manner, right? Energy and momentum is going on. In layman method, the disturbance is going from here to there, right? And that disturbance carries some information, right? That disturbance carries some pattern, and on the basis of that pattern you can decode and convert that some kind of meaningful information for you, right? So this is the reason for which we are studying this concept, right? Waves.
Okay.
So let's talk about, there are two kinds of waves, right? There are two kinds of wave. We call them transverse and longitudinal, right?
Yeah.
transverse wave and longitudinal. There are two kinds of vibrations in the medium particle, and through which you can travel, you can transfer the disturbance, right? The disturbance can travel in the two manners, the longitudinal
And transverse.
wave. In the transverse wave, the wave travel in this manner. Okay, so wave is propagating in this direction, right? And the medium particles are vibrating perpendicular to the movement. Can you see that? Medium particles are vibrating in this manner. They are moving actually, but perpendicular to the movement of the wave or disturbance, right? And in the longitudinal wave, particles vibrate in the direction of movement, right?
Okay.
So in the direction, the wave is propagating in this direction, right? In the case of sound waves are the longitudinal waves. What is going on here? This is the medium particle, air particle, you can say. When you are trying to say something, you are compressing the air and rarefaction. This compression and rarefaction is moving forward, right? So it's very critical here. These particles are compressed because you are saying something, so you are disturbing the medium particle, you are compressing, and there will be some expansion, right? There will be some expansion, compression, expansion, compression, or you can say rarefaction and compression, right? This will take. So in which direction, which kind of this wave you can analyze from this? The wave is traveling in forward direction. You can see clearly wave is traveling in forward direction, but the medium particles is vibrating in what direction? In the direction of wave. This particle is moving in this direction, right? This particle is compressing.
It's compressing.
This manner. So vibrating this manner. So this is a longitudinal, right? And the string wave, remember the string wave? When you will some stimulation or some disturbance, then disturbance will travel through the medium, and the medium particle is vibrating in this in what direction? Perpendicular at 90. This is the example of transverse wave. Are you getting my point? So these are the so it will have because this is a transverse and this is the longitudinal, and you have to explain what are you watching. I'm watching a longitudinal, but longitudinal also have different forms, right? So how you will explain them then? You need to use some properties of the waves, right? Like your face or any, there are different faces, right? If you have seen any thief and you want to explain, you want to express the thief in front of some police, right? Police officer, then how you will explain, what you will use to explain
features,
characteristics, what kind of nose, what kind of eyes, and what kinds of height and other things you will try to explain, right? You will try to give as the information, and that informations are the characteristics of that person, characteristics, or you can say identity, right? So same manner, waves have their own properties. On the basis of them, you will express which kind of wave is going on there. So how you will express in the terms of amplitude, frequency, time period. What are those? They are the properties. Let's talk about them if we have a little bit time. So what is amplitude? First of all, amplitude. So it is basically the maximum displacement of the particle from their mean position. So in the stationary state, particle was in this manner, right? And what is the maximum disturbance for the particle? This maximum disturbance, this height is maximum here. So this maximum height or maximum possible disturbance is known as amplitude, right? If this amplitude is very large, it means the wave have large energy, right? If the amplitude is very large, the wave have large energy then, okay? Because you have imparted very huge amount of disturbance to one single particle, right? Single particle is disturbed very much. It means it have very energy. It will carry forward to another particle. That particle will also get disturbed with huge amount because amplitude is more. So the other particle receives lots of energy there. Are you getting my point? So amplitude is the information of maximum disturbance or maximum displacement from their mean position. This is what we call mean position, right? About which it is moving back and forth, right? And there is lots of other things like frequency. We will discuss all these features in very detailed manner. Frequency. One second. This information is the frequency, right? And this tells about the pitch of your voice. Am I audible properly?
Yeah, I can hear you.
Yeah. So frequency is about the shrillness or blunt voice, right? Your voice is very shrill, and my voice is very my voice pitch is very very low, and your voice pitch is very large because your vocal cord is vibrating very fast, right? So your the vocal cord have frequency very large, so your pitch is very large, so your voice sounds like very shrill, right? It's shrill, it's a thin voice, you can say, or shrill voice, right? So frequency tells about the shrillness or thinness of the voice. Are you getting my point?
Yeah, I am.
Yes, so these are the concepts. And another thing is time period, wavelength, lots of things we have to discuss actually in this. Okay, so have you understood properly these concepts? These concepts?
I have. Yeah.
So you can discuss with the management about all these things. If you want any other topic to discussion, then you can. Otherwise, we have only 5 minutes left.
I'm done with all my doubts, all the topics I
okay,
have.
let's use this 5 minutes also. Otherwise, I have to inform them why you have left before 5 minutes. Okay, let's talk about the motion word.
Okay.
Yeah. So definitely you have heard about this term, right? Motion.
Yeah.
So how you will explain? How will you explain this in your words to any kid, any small kid? what do you mean by small kid? Any kid? Let's say it's nearly 9 to 10 years, right? His age is 9 or 10 years, right? So try to explain this kid. What is motion? What you will say? So moving here and there, these kinds of activities.
Motion is when an object it's when an object moves.
Then what do you mean by moves here? What do you mean by moving?
It's the speed or the direction the object moves in.
Speed and direction and all the things will come after this, right? First of all, you have to explain what is the movement, and then you can explain the speed, because speed rely on the understanding of movement itself, right? Because if someone don't know what is movement, then definitely he will also don't know he don't know about the speed also, right? How you will explain this looks very critical. You can explain in very easy manner. It is a phenomenon, right? It is a phenomenon, but which kind of phenomenon? It is a phenomenon in which something, or you can say someone, changes their location, right? Location with the change in time. This is the important thing here, with the change in time. Without change in time, if you are here and here, but there is no change in time, then you are not moving actually. You are doing, but I don't know what. You are here and here simultaneously. It's very illogical thing, right? So with the change in time, if you are changing your location, it means you are moving, right? So what is the necessary thing here? the changing in the location, right? Changing in the position with the change in time. Are you getting my point? So this is what we call motion. And because you can change your location with the change in time in several way, right? You can change your location very quickly. You can change your location very slow, right? And that will give the information, information gives by the speed, right? Speed is about how fast, how quickly you are changing your location with the change in time, right?
Yeah.
So speed needs the information of distance. How you will inform anyone that he's moving fast or moving slow? With the information of distance and the time as well. If someone is moving, you know that Usain Bolts have record how much? 100 meters in just, I don't know exactly, 100 meters, he just crosses that 100 meter in just 9 point some seconds, right? Let's say 9.6 seconds. And if I will expect from you, then how much time you will take for completing the 100 meters?
Around
Say
15 or 16 seconds.
15 to 20 seconds, right? Of course, 15 to 20 or 15 to 16 seconds. So, but if someone is moving through 100, someone passes the 100 meters just on 6 seconds. So what you will say? The person is moving very fast, right?
The speed is
very fast. So for deciding that he's moving fast or slow, you need the information of distance, and distance travel in how much time? 6 seconds. Yeah, you can travel through hundreds of kilometers, but with the information of time, if you have the information of time, then you can decide you are moving faster or moving slower. Are you getting my point? So with the information of distance and time, collectively you can decide the information of speed, and the speed will come after understanding what is motion, right? Because motion is nothing but it is about changing location with the change in time. If you will change location, then you will cover the distance. If you will cover distance, it will take some time. It means you have some speed also, and then acceleration and all the concepts will build up over this one by one. Understood? Yeah, that's very, very interesting to explain in detailed manner. That in detailed manner, that becomes more and more interesting. Actually, I have only explained all these things in just 5 minutes. I don't know how it's for you. It's good for you or not. You are experiencing.
I can understand. Yeah, I can understand.
Then perfect. Then perfect. Okay. Okay. Tanisa, so how was this session for you?
Yeah, it was good. I could understand most of the concepts.
Yeah, perfect. So you can give your feedbacks to the management and they will inform me and they will decide when we have to start or not. Okay, Tanisa.
Thank you. Thank you, sir.
Nice to meet you. And we will meet again, I hope.
Yeah.
Bye-bye.
Yeah. Thank you. Bye.
Okay. Now you can leave.